Welcome to the deep dive, where we cut through the noise and get straight to the insights you need to be truly well-informed. Today, we're taking a close look at, well, one of the most critical issues in healthcare globally, organ transplantation. It's really life or death stuff.
Absolutely.
And it's a system facing, chronic shortages, huge inefficiencies, and just really deep-seated problems that impact real lives every single day.
Yeah.
But here's the twist. What if a technology we usually associate with, like Bitcoin, blockchain,
Yeah.
what if that could actually be a solution?
It's a stark reality, isn't it? I mean, dozens of patients die every single day worldwide waiting for organs.
Wow.
Here in the U.S. alone, you've got roughly 100,000 people on wait lists. And tragically, about 12 of them die each day waiting.
12 a day, just
Yeah.
in the U.S.
Yeah. So what's the core problem we're trying to solve here? I mean, it really sounds like this perfect storm, right? Shortages, yes, but also systemic trust issues and just real-world failures.
Exactly. I think it really boils down to a fundamental lack of trust and transparency. We're talking about a system where sometimes organs get lost or discarded in transit. I mean, imagine that.
Terrible.
And you hear accusations of fraud, waste, and abuse plaguing the bodies that oversee this, like UNOS in the U.S. Plus, outdated tech that just keeps critical processes hidden, secretive.
Right, like a black box.
Yeah, it's not just about numbers on a list. It's about people losing hope and sometimes losing their lives because the system fails them.
And, these concerns aren't just confined to the U.S. either. You see them recurring globally.
Really? Like what?
Well, we've seen things like hidden waitlist manipulations, the rise of illicit organ markets, actual black markets, and just this growing public distrust.
That makes sense.
There are even these high-profile cases where organs were apparently taken without proper consent, and that leads citizens to actually withdraw their consent to be donors, which is incredibly damaging to the whole system.
Oh, absolutely. That erodes everything.
So the current situation, pretty much everywhere, is that these existing organ tracking systems, the registries, they're often these centralized black boxes,
Right.
riddled with single points of failure, very limited audit trails, and serious vulnerabilities to fraud or just plain error.
Okay. So can blockchain, this tech we hear about with crypto, can it really offer a solution to something so complex, so human as organ transplantation? Let's dive into the sources you've provided and find out.
All right, let's maybe unpack this technology a little bit first. For listeners who aren't, deep in the tech weeds, how should we think about blockchain simply?
Yeah.
Especially when we're applying it to something as sensitive as healthcare data.
Okay. So at its core, blockchain is a form of distributed ledger technology, DLT for short.
DLT, okay.
Think of it like a shared digital ledger, but it's append only. That means you can only add to it, not easily change the past. And crucially, it's not maintained by one single authority. It's maintained by a network of peers. Everyone involved has a stake. So it's kind of like a shared Google Doc, maybe, but way more secure and no single person owns it. Is that close?
That's a good starting analogy, yeah, but with some really crucial differences. So data, let's say an organ match event or a patient's consent record, gets grouped into these blocks.
Okay. Blocks.
Then these blocks are cryptographically linked or chained to the previous blocks, like a chain.
Hence, blockchain. Got it.
Exactly. And this chaining makes the whole ledger immutable, basically tamper-proof. If you tried to alter any past record, you'd break all the links that come after it, making the change immediately obvious to everyone on the network. It's like trying to, secretly pull a single brick out of a perfectly built wall. The whole structure would show the damage.
Right. Okay. That makes sense.
And this is key. All the participants in the network hold copies of this ledger, and they must reach consensus on each new entry.
Consensus, meaning everyone has to agree.
Sort of, yeah. It's collective validation. It protects against single points of attack because no one person or entity can force through a change or a fake entry.
That makes a lot of sense. But hang on, there's a difference, right? Between the public blockchains we hear about, like Bitcoin, and what you'd actually use for healthcare. Because I can't imagine patient data just floating around openly.
Yes, absolutely. That's a critical distinction. Public chains like Bitcoin or Ethereum, they're open to anyone. Anyone can join, anyone can see the transactions, more or less.
Right. Not good for health records?
Definitely not.
Ah.
So healthcare applications would almost certainly favor what we call private permissioned or consortium chains.
Okay, permissioned, meaning?
Meaning access is restricted. Only known authorized organizations, think a network of specific hospitals or government health bodies, can participate. This protects sensitive data while still giving you that benefit of decentralized validation. No single entity is in sole control.
Okay, that makes more sense. And you mentioned smart contracts. What role do they play?
Right. Smart contracts. Think of them as self-executing bits of code stored right on the blockchain. They act like digital if-then rules.
If then, like,
Like, if a compatible donor organ becomes available and the recipient meet criteria XYZ, then automatically trigger a match notification. Or if a sensor detects an organ container's temperature going outside the safe range, then automatically send an alert to the transport team and the receiving hospital.
okay. Automation built right in.
Exactly. And once deployed on the blockchain, these contracts are also tamper-proof. They provide transparent and automated enforcement of rules, like organ allocation criteria. No hidden changes possible.
Wow, that's potentially powerful for automating these really complex processes fairly. So, just to really nail this down, how do these blockchain systems fundamentally differ from the centralized ones we have today? Like, let's talk data control, transparency, that kind of thing.
Sure, let's break it down. So data control. In a traditional system, it's centralized.
Mm-hmm.
One authority, like UNOS, holds the keys. On a blockchain, it's distributed. The ledger is shared among all the approved participants.
Okay. Difference one.
Difference two, transparency. Traditional systems, pretty limited. Stakeholders usually only see their own little piece of the puzzle. Blockchain, especially these permission ones, can offer high transparency among the participants. Authorized nodes can see the relevant transaction history.
So more eyes on the process.
Exactly. And third, immutability. Traditional records. An administrator can edit or even erase them. Might leave an audit log, maybe not. A blockchain. It's designed to be an immutable, append-only ledger. Changes don't erase the past. They're logged as new transactions, linked to the old ones. Everything is traceable.
Okay, that clarifies the foundational differences pretty well.
Yeah.
It's one thing to talk theory, though. Are there any, like, real-world projects or pilots actually trying this, applying blockchain to organ transplantation right now?
Yeah, good question. We're definitely still more in the prototype and pilot stage than full production systems, but yes, there are several promising initiatives that really illustrate the potential.
Like what?
Well, for instance, in Sri Lanka, there's a project called LifeShare. It's a prototype specifically for blood and organ donation,
Okay.
and it's directly trying to tackle the problem of illegal organ trafficking there by replacing a centralized service with a distributed ledger. They're using smart contracts for donor registration, aiming for full traceability of every donation event.
Fascinating. So really trying to address a specific, serious problem head-on. What about here in the U.S., any movement?
Yeah, in the U.S., there was a simulation project called Organ Chain, built on a platform called Hyperledger Fabric that's a popular one for enterprise blockchain.
Organ chain, okay.
Its goal was basically to see if you could reduce UNOS's perceived data monopoly by mirroring its systems onto a blockchain. It used smart contracts for the donor-recipient matching part.
And did it work? I mean, in the simulation?
Well, importantly, the early results showed that its performance could meet the operational requirements. It suggests that these permission chains could potentially handle the load and replace those siloed databases without grinding to a halt.
That's a key feasibility check. Anything else?
There's also BOMS, the blockchain-enabled organ matching system. This one's more of an academic project built on Ethereum, actually.
Oh.
But it fully implements an organ matching process. It encodes the biological compatibility rules right into the smart contracts. And it uses patient-associated blockchain addresses, not real IDs, obviously, to help preserve privacy.
And what's special about bombs?
The key thing there is that its matching algorithm, the code itself, is publicly verifiable and immutable on the blockchain. So in theory, anyone could check how the matching works, ensuring transparency in who gets an organ and why. It's not a hidden process.
Right. These are prototypes, of course, still early days, but you can definitely start to see how they could bring concrete applications, moving beyond just the theory.
Absolutely. And what's truly fascinating, I think, is how researchers are envisioning blockchain transforming different stages of the whole organ donation workflow, not just one piece.
Like what stages?
Okay, take consent management. That's a huge one for trust. Donors could potentially provide and record their consent immutably, right on the chain.
So my decision is locked in, provably.
Exactly. Smart contracts could then ensure that this consent is transparent, auditable, and simply cannot be fraudulently altered or, lost. Individuals might even control their consent portably using a private key, giving them unprecedented control over their own decisions.
That's a huge step for trust, I agree. What about the actual matching? You mentioned Bombas, but more broadly, that's where so much criticism often lands, right? And where transparency feels absolutely crucial.
Absolutely. That's a core area. Smart contracts could encode all the allocation rules, the complex medical and ethical criteria, automating the matching algorithms transparently.
So the rules are out in the open, running automatically.
Precisely. Imagine maybe even a single global pool. Okay, maybe that's ambitious. But a system where organ offers and patient requests are added to a shared ledger. Then, consensus rules automatically and fairly rank candidates based on the agreed-upon criteria.
And because it's on-chain.
Because those rules run on-chain, the process is immutable and transparent. It directly fosters trust that no one is secretly manipulating the waitlist behind the scenes.
That addresses a major point of distrust.
And there's even some research exploring using blockchain to link separate national registries.
Oh, interesting. How would that work?
The idea is allowing, say, anonymous organ offers to be matched across borders, but under unified, agreed-upon algorithms. This could potentially improve global equity, letting donor-rich regions maybe assist those with critical shortages, all tracked securely and transparently on a single shared chain.
Wow, okay. Linking systems globally is a big vision. Now let's shift gears a bit to the really practical side. What about once an organ is matched and it's actually on its way? That journey, I mean, it's fraught with risk. It's literally a ticking clock. How could blockchain possibly help with the actual transport and traceability there?
Yeah, this is actually a prime area where people see potential combining blockchain with other tech, specifically the Internet of Things, or IoT sensors.
Smart devices.
Exactly. Picture this. Each special container carrying an organ is fitted with sensors, temperature sensors, humidity sensors, maybe even motion or shock sensors.
Okay.
These sensors continuously stream their data, the temperature, location, whatever, directly to smart contracts on the blockchain.
Live data onto the blockchain.
Yes. Those smart contracts are programmed with the safe parameters for that specific organ. They constantly verify if conditions are okay. If a threshold is breached, say, the temperature spikes, the smart contract instantly logs an alert.
And that log is immutable.
Immutable, undeniable. It provides a complete, time-stamped record for the transplant teams, quality control, maybe even patient families down the line. It ensures proof of integrity, right from the donor hospital to the recipient. This could address so many of those heartbreaking stories about organs being damaged or unusable because of transit issues.
Okay, that IoT integration sounds genuinely game-changing for the logistics part. So let's pull back a bit. What does all this mean for, for you listening, for the patient, the medical professional, the donor family? If this technology is adopted, what are the big anticipated benefits?
Well, the potential benefits are pretty substantial, based on what the research suggests. First off, enhanced data security.
How so compared to now?
Because encryption and that decentralized storage make unauthorized tampering extremely difficult. Instead of one central database that could be hacked or just fail, you have this network, many copies, distributed across maybe many hospitals. This gives you something called Byzantine fault tolerance.
Byzantine fault tolerance. Sounds complicated.
It just means the system is resilient. Even if some parts of the network fail, or even if some participants try to act maliciously, the network as a whole can still function securely and reliably. It's much harder to bring down or corrupt than a single central server.
Okay, more robust security. What else?
Second, you get that immutable audit trail we keep mentioning. Every single event, a donation, consent being given or revoked, an organ transfer, a temperature reading, is time-stamped and cryptographically linked.
So a perfect history.
A perfect forensic trail. This directly addresses issues like suspected hidden list manipulation or waitlist tampering. You can follow the entire chain of custody and decision-making.
That sounds like a massive boost for restoring public trust. No more wondering if someone unfairly cut in line, perhaps. But let me push back slightly, practically speaking. How do we ensure the data going onto the blockchain in the first place is accurate? The chain itself can't magically fix human error or, malicious intent right at the point of entry, can it?
That's a really critical point. You're absolutely right. Blockchain ensures data integrity after it's been recorded. Garbage in, garbage out still applies to some extent.
Right.
However, the system builds transparency around those inputs. Who entered the data? When? Was it attested by someone else? That audit trail starts immediately. It doesn't eliminate the need for good procedures and checks at the source, but it makes hiding bad data entry much, much harder.
Okay, so it adds accountability even at the input stage. Good. What other benefits?
Third, building on that is transparency and trust overall. Authorized stakeholders, doctors, coordinators, maybe even patients or families with permission can observe the relevant data flows in near real time.
So a family could potentially track things?
Potentially, yes, depending on the design. They could perhaps independently verify that the organ their loved one received matches the registry records, that it stayed within the safe conditions during transport. It creates what people call a single source of truth for the whole supply chain. This directly counteracts those really damaging rumors about unfairness or organs being diverted to black markets.
Okay, truth and transparency. Makes sense.
Fourth, flowing from that, is reduced fraud and illicit trade. An immutable ledger inherently deters fraud. Records can't be secretly altered or deleted. This makes it much, much harder for illegal organ brokers to operate without leaving a clear, verifiable trace in the system.
Harder to cheat the system.
Exactly. And lastly, potentially, improved process efficiency. Those smart contracts we talked about. They can automate routine tasks, like running the matching algorithms.
Right, the if then rules.
Yeah, that kidney chain prototype, for instance. That research suggested that their blockchain-based matching was actually faster and more efficient than the manual processes sometimes used alongside the official UNOS matching system. So it could potentially speed up life-saving coordination.
Okay, this all sounds incredibly promising, almost, a bit too good to be true sometimes. What are the big roadblocks, the significant hurdles that need to be overcome for this to actually become a widespread reality?
You're right to be skeptical. There are definitely considerable challenges. Big ones. First up, legal and regulatory. This is huge. Well, for starters, many places just lack clear rules for handling sensitive health data on a blockchain. And then there's the clash between blockchain's core feature immutability, the fact you can't easily delete things, and privacy regulations like Europe's GDPR, which includes a right to be forgotten.
Ah, right. If you can't delete data, how do you comply with a right to be forgotten?
Exactly. The current thinking, the workaround, involves storing only minimal data directly on the chain, maybe just cryptographic hashes like unique fingerprints of data or pointers. The actual sensitive personal health information, PHI, stays off-chain, in secure traditional databases where it can be managed or deleted according to regulations.
Okay, so a hybrid approach. Keep sensitive stuff off, use the chain for proofs and links.
Pretty much. But even then, liability is murky. In these decentralized consortium models with multiple hospitals participating, who is legally responsible if something goes wrong? It's not always clear.
So the technology is often outpacing the law, essentially. What about privacy itself? Even if you keep PHI off-chain, you mentioned pseudonymous addresses, could there still be risks?
Yes, absolutely. While pseudonymous addresses hide real names, analyzing transaction patterns could potentially risk re-identifying individuals, especially in a smaller network. It's a known challenge in blockchain privacy. And then there's the whole critical need for robust public key infrastructure. Managing those cryptographic keys. If a patient loses their private key, do they lose access to their own consent record on the chain? How do you handle that securely? Regulators will absolutely demand solid answers there.
Yeah, losing your key sounds like a nightmare. What else?
Another hurdle is scalability and performance. Blockchains, especially certain types, can struggle with really high transaction volumes or handling large amounts of data, like full medical images.
Right. You wouldn't store MRI scans on a blockchain.
Definitely not directly. Proof-of-work chains, like the ones Bitcoin uses, they're notoriously slow, they consume huge amounts of energy, and can only process maybe a handful of transactions per second.
Not feasible for real-time healthcare needs.
Not at all. Even the faster permission chains need really robust underlying infrastructure to avoid bottlenecks, especially during, say, a large-scale matching run, or if many IoT devices are streaming data simultaneously.
And let's be honest, hospitals and health systems aren't exactly known for adopting bleeding-edge tech overnight, are they? That integration seems like another huge barrier.
You hit the nail on the head. That brings us to integration with legacy systems. Hospitals, national registries, they run on established IT systems, electronic health records, EHRs, donor databases. Connecting a new blockchain system requires complex interfaces, and these existing systems are often wildly different, heterogeneous, proprietary. It's a massive technical and organizational challenge.
Getting old and new systems to talk nicely, never easy.
Never easy. Then there's governance and stakeholder buy-in. If you have a shared blockchain organ registry involving many different hospitals, maybe government agencies, who runs it?
Good question.
Who gets to host the nodes? Who validates the transactions? Who pays for the ongoing maintenance? You need entirely new governance models to figure all that out.
Yeah.
And you can expect potential resistance from incumbents' existing organizations who might see blockchain as a threat to their current controller business model.
Politics and turf wars, basically.
Essentially, yes. And finally, just plain old regulatory compliance. ensuring any blockchain solution meets all the relevant standards, EIPA in the US, data protection laws elsewhere, potentially medical device regulations if IoT sensors are involved. It's incredibly complex. And the reality is most health blockchain work, frankly, still remains theoretical or in very early pilot stages. The compliance piece is still being figured out.
Okay, a hefty list of challenges. So if we connect this to the bigger picture, if we want to move forward, what are the experts, the researchers recommending? How do we bridge that gap from these promising pilots to something that could actually be a widespread, life-saving reality?
The recommendations tend to follow a clear path. First, start small and focused. Targeted pilots.
Like what?
Like maybe focus initially on kidney exchanges, which are already complex coordination problems, or perhaps organ sharing just within a single state or region. Do it in a coordinated setting, and crucially engage the regulators right from the very beginning. Don't build something and then ask for permission.
Get them involved early. Makes sense.
Second, really focus on those privacy-preserving architectures. Keep researching methods like zero-knowledge proofs, ways to prove something is true without revealing the underlying data. And establish clear standards for data formats, maybe leveraging existing healthcare standards like HL7, FHIR.
SHIR.
Yeah, FHIR. It's a widely adopted standard for exchanging healthcare information electronically. Using standards like that helps ensure different systems, including a potential blockchain layer, can actually talk to each other effectively.
Okay, standards are key. What else?
Third, developing those robust governance frameworks we talked about. We need clear consortium models outlining how these networks will be run, managed, funded, defining the roles and responsibilities for everyone involved.
So figure out the rules of the road before you start driving.
Exactly. Fourth, dedicated legal and regulatory research. We need legal scholars, policymakers digging into things like, are smart contracts legally enforceable for organ allocation? How do we handle cross-border data sharing rules in a blockchain context? These questions need answers.
Right. The law needs to catch up.
Fifth, and this is vital, interdisciplinary collaboration. This can't just be tech people building something. You need clinicians, transplant coordinators, IT experts from hospitals, ethicists, patient representatives, all involved in the design process from the start. You have to address the human factors, the workflow integration, the ethical considerations. It has to work for the people using it.
Makes total sense. Not just tech for tech's sake.
Absolutely not.
Yeah.
Sixth, we need rigorous evaluation of value and cost effectiveness. Is a blockchain solution actually better, more efficient, safer than improving existing systems, or implementing other non-blockchain upgrades? We need solid evidence, accounting for the costs of building and running this infrastructure versus the benefits, like lives saved or fraud prevented.
A proper cost-benefit analysis.
Yes. And finally, number 7, look at integrating complementary technologies synergistically. Really explore those links with IoT for tracking organ shipments, maybe even using AI for more sophisticated matching algorithms or predicting transplant outcomes, potentially feeding standardized data, like those live temperature logs, directly into smart contracts for enhanced automated safety checks.
Okay, so it's a multi-pronged approach. Start small, focus on privacy, build governance, clarify laws, collaborate widely, prove the value, and integrate smartly. This deep dive has really shown us both sides, hasn't it? Blockchain clearly holds immense promise. It could genuinely revolutionize organ transplantation by boosting transparency, security, and trust in a system that, let's face it, desperately needs it.
It really could.
But as you've laid out, it also highlights these monumental challenges, technical, legal, organizational, that lie ahead.
Indeed. Realizing this potential isn't going to be easy. It will require overcoming all those significant barriers we discussed. But I do believe that with careful, thoughtful design and a truly collaborative effort involving everyone, blockchain could indeed become a valuable tool, a tool to help make organ transplantation safer, more efficient, and more equitable, not just here, but worldwide.
So maybe not a magic bullet, but a potentially powerful tool in the toolbox.
That's a good way to put it.
All right. Well, this raises an important question maybe for you, the listener, to ponder. Beyond just organ donation, what other critical, complex systems that currently lack transparency or suffer from serious trust issues could potentially be transformed by this kind of immutable, transparent ledger technology? Think about the broader implications. Where else could this apply?